So far, the Earth appears to be the only planet that is capable of supporting life. However, you will definitely be surprised to know that scientists have found many other planets that can support life. In fact, many researchers believe that they are better than Earth. NASA launched the Kepler Space Telescope to search for planets the size of Earth orbiting other stars. The spacecraft, named for astronomer Johannes Kepler, was launched into an Earth-trailing heliocentric orbit on March 7, 2009, and it has been successful in discovering planets that can support life. Now, before we go any further, make sure you subscribe to Technology Fit, and don't forget to hit that bell icon so you never miss any updates. So, without further ado, let's get into this. First of all, let me tell you that William J. Barucki was the lead investigator. The telescope's reaction control system fuel was spent after 9.5 years of operation, and NASA announced its retirement on October 30, 2018. Kepler's sole scientific instrument was a photometer that continuously monitored the brightness of approximately 150,000 main sequence stars in a fixed field of view. It was designed to survey a portion of Earth's region of the Milky Way to discover Earth-sized exoplanets in or near habitable zones and estimate how many of the Milky Way's billions of stars have such planets. This data was sent to Earth, where scientists evaluated the data to see if there was any periodic dimming caused by exoplanets passing in front of their home star. Interestingly, Kepler discovered 2,662 planets and observed 530,506 stars. Here, it is worth mentioning that the telescope weighs 1,039 kilograms and has a Schmidt camera with a front corrector plate measuring 0.95 meters and feeds a 1.4 meter primary mirror. This was the largest mirror on any telescope outside of Earth orbit at the time of its launch, until the Herschel Space Observatory took over a few months later. Its telescope has a field of vision of 115 degrees squared, approximately 12-degree diameter, which is about the size of a fist held at arm's length. 105 degrees squared of this is of scientific quality, with less than 11% vignetting. Instead of sharp photos, the photometer has a soft focus to produce superior photometry. The mission's goal was to achieve a combined differential photometric precision of 20 parts per million for Sun-like stars over a 6.5-hour integration, but the observations fell short. NASA's Jet Propulsion Laboratory oversaw the telescope's construction and initial operation, while Ball Aerospace was in charge of constructing the Kepler flight system. Since December 2009, the Ames Research Center has been in charge of ground system development, mission operations, and scientific data analysis. The mission was originally designed to last 3.5 years. However, due to higher-than-expected noise in the data from both the stars and the spacecraft, more time was required to complete all mission objectives. The mission was originally scheduled to be extended until 2016, but on July 14, 2012, one of the spacecraft's 4 reaction wheels stopped turning, making the mission impossible to complete unless all of the other reaction wheels remained functional. Then, on May 11, 2013, a second reaction wheel failed, halting science data collection and endangering the mission's continuation. NASA announced on January 6, 2015, that the Kepler satellite telescope had discovered the 1,000th verified exoplanet. 3 of the 4 newly confirmed exoplanets, Kepler 438b, Kepler 442b, and Kepler 452b, are almost Earth-size and possibly rocky, while Kepler 440b is a super-Earth. NASA confirmed 1,284 new exoplanets discovered by Kepler on May 10, 2016, making it the single greatest discovery of planets to date. The best planet in the universe isn't always Earth. 24 planets outside our solar system have been discovered by researchers to have circumstances more conducive to life than our own. Some of these planets circle stars that may be more powerful than our Sun. A study conducted by Dirk Schultz-Makach of Washington State University, published in the journal Astrobiology, details the features of hypothetical super-habitable planets. This study includes planets that are older, somewhat larger, slightly warmer, and maybe wetter than Earth. Planets orbiting slower changing stars with longer lifespans than our Sun may also be more conducive to life. The focal plane of the spacecraft's camera is made up of 42 50 into 25 mm CCDs with a total resolution of 94.6 megapixels, making it the largest camera system that has ever flown into space at the time. For short cadence goals, the CCDs were read out every 6.5 seconds and co-added on board for 58.89 seconds. And for long cadence goals, the CCDs were read out every 1,765.5 seconds. Because of the higher bandwidth requirements for the former, the number of these was limited to 512 instead of 170,000 for long cadence. Despite having the highest data rate of any NASA mission at the time of launch, the 29-minute summation of all 95 million pixels comprised more data than could be stored and delivered back to Earth. As a result, the science team pre-selected the relevant pixels connected with each star of interest, which accounted for roughly 6% of all pixels. The data from these pixels was then quantized, compressed, and saved in the onboard 16GB solid-state recorder, along with other auxiliary data. Science stars, P-mode stars, smear, black level, background, and full field of view photos were among the data recorded and downlinked. The Kepler primary mirror, which was created by Corning using ultra-low expansion glass, is supposed to have a mass of only 14% that of a solid mirror of the same size. An extremely high reflectivity coating on the primary mirror was required to construct a space telescope system with sufficient sensitivity to identify relatively tiny planets as they pass in front of stars. Surface Optics Corp used ion-assisted evaporation to apply a protective 9-layer silver coating to enhance reflection, and a dielectric interference coating to reduce color center development and atmospheric moisture absorption. In terms of photometric performance, Kepler performed admirably, far better than any Earth-bound telescope, yet it fell short of its planned objectives. The goal was to achieve a total differential photometric precision of 20 parts per million during a 6.5-hour integration on a magnitude 12 star. This estimate was made with a stellar variability allowance of 10 parts per million, which is about the same as the Sun's. This observation's precision varies greatly depending on the star and its position on the focus plane, with a median of 29 parts per million. The majority of the extra noise appears to be attributable to bigger than anticipated variability in the stars, with the remainder coming from instrumental noise sources that are slightly greater than expected. Because the brightness decrease from an Earth-sized planet transiting a Sun-like star is so little, barely 80 parts per million, the increased noise reduces the number of distinct transits to 2.7 sigma rather than the expected 4 sigma. As a result, more transits must be observed to be certain of detection. According to scientific estimates, a mission lasting 7 to 8 years, rather than the 3.5 years originally intended, would be required to identify all transiting Earth-sized planets. The Kepler mission was extended into the fiscal year 2016 on April 4, 2012, although this was contingent on all remaining reaction wheels remaining healthy, which was not the case. After the spacecraft ran out of fuel on October 30, 2018, NASA announced that the telescope would be retired. The telescope was turned off on the same day, ending its 9-year run. During its lifespan, Kepler examined 530,506 stars and identified 2,662 exoplanets. TESS, a newer NASA mission that started in 2018, is still looking for exoplanets. Don't forget to share your thoughts and valuable feedback with us in the comments section below. That's all for today's video, and I hope you enjoyed this video. If you liked the video, make sure you share it with your friends and give this video a thumbs up. And if you have not already subscribed to our channel, subscribe to it and press that notification bell so you receive a notification each time we upload an interesting video on this channel. Thanks for watching this video. We will see you in the next video. Take care and stay tuned.